Good morning, good afternoon, whatever time of the day it is that you're viewing this. Mr. Moraine here again. I put parentheses around SAT in the heading because not all of the questions that I will be showing you are at the level of SATs. This particular question is well above the level of the SATs, but if you can make sense out of this one and even learn to work through all the details on your own, trying it a few times, the counting questions on the SATs will seem much easier. Again, I want to thank you for finding my site, viewing this video, however long you stay with it. And it really means a lot to me because I put time and effort into this. It's a labor of love. I like sharing my personal experiences and what I've learned from teaching for 40 years or more. And that's why when you press like or subscribe to this channel, it encourages me to continue producing these. And if you came from Twitter, that's great. I have a lot of followers on Twitter. So if you do that, then you probably will not leave a comment or like on YouTube, but I would appreciate if you could do that. All right, that was my introduction. Now we're going to move through this question. Read the problem. I'm sure you already have. Just pause a video like this. Process, digest. Okay. All right. You know I'm going to highlight keywords, and then we're going to talk about the mathematical methods that go into solving these kinds of problems. And, mathematics is essentially a way of thinking and organizing your thoughts so that you can make sense out of the problem and come up with a way to do this efficiently and with accuracy as opposed to a more haphazard approach. Here we go. So I'm going to highlight, if I have it set up for that, which I don't. Wasting a lot of time here, and I apologize for that. So how many three-digit? Well, how many, of course, is about counting. Three-digit, that's easy enough to understand. Positive, we're only going to be thinking about positive integers, positive whole numbers. Even, you get the feeling that might be an important word? Exactly two identical digits. And yeah, the question mark's appropriate because what the heck does that mean? Some of you with strong reading and comprehension skills will go, what's the big deal? But trust me, you have no idea how many people have difficulty interpreting these kinds of phrases. This would be grid in, meaning I'm too lazy to make up the choices, or it doesn't lend itself to choices. Non-calculator, we're not dealing with any complicated arithmetic. So we're going to start, did the highlighting. This falls under the umbrella of systematic counting, making an organized list. There are so many different phrases you've heard in school, I'm sure. With the new Common Core, to you it's not new. I mean, well, for me it's definitely not new. These kinds of counting problems appear now in elementary school, so you might have had exposure to this for quite some time. So let's begin. And the way I begin this is the way I strongly encourage you to. Now, I'm not going to repeat the problem. I'm just going to go to another page. So we're just going to start listing numbers, and you could start haphazardly and randomly. 460, say. That's an even number. And three digits. But it doesn't have two identical digits. What does that mean? Well, let's make it 464 or 466. Now we have two identical digits. Notice 444 would not be counted because it has three digits that are the same. That's where the exactly two comes in. We're back to the language of the problem. Exactly. That's mathematical language for you. Nasty, of course. But once you get used to it, these phrases will click very quickly for you. All right, so it looks like I'm just randomly picking numbers in the 400s, right? Well, let's actually do the 400s a little more systematically. So 400s. Now this is where a systematic approach comes in very handy. And we know that the first digit is going to be a 4, so there's only one choice if we're in the 400s. Notice above the line, I write the number of possible choices, and below the line, I list the actual choices. Now, we have to look at different possibilities. For example, 442, the first 2 digits may match. Okay? And in that case, the second digit, the tens digit, would have to match the 4 again. So there's only one possibility. But the ones digit, the unit digit as we call it, that could be 2, 6, 8, or 0. There's a lot of math right here. First of all, what did I omit? And why? That's right. We can't have 3 of the same. Why 0? Why does the ones digit have to be one of these numbers? Because that comes from an understanding of what even numbers are. Even numbers are those that end in an even digit. You only have to look at the ones digit to determine if a number is even. You could have all odd digits as long as the ones digit is even, the number's even. So there are 4 possibilities here. So in this case, there are 4 outcomes. Looks like I'm multiplying the 1s and the 4, right? You could just as easily do this by listing. And many of you would prefer that if you're not used to this. I call it a slot method, but really it's an illustration of the multiplication principle of counting, the fundamental principle of counting. Has lots of names, but here it is. You could also use a tree, which is frequently done for these kinds of questions, but even more when you get to probability. All right, so we can actually list what these 4 numbers are. So the first digit has to be 4, the second digit has to be 4, and then the third digit could be 0, 2, 6, or 8. Notice which one I omitted there. So in this case of the first 2 digits matching, 4, 4, we found 4 possibilities. Well, let's go on to another possibility. And we'll add a page. Okay, and now let's say we're still in the 400s. There's only one possibility there. Let's say the first and the third digits match. In other words, this will also be a 4. And only one way to do that. And the middle digit could be anything, right? So it could be 404, 414, 424, odd or even. But what can't it be? 434. And again, many of you will do it by listing like this. And systematically, in an organized way, makes the most sense. That's right. The middle digit, the tens digit, cannot be 4. And we're back to that bugaboo. So this could be, the middle digit could be 0, 1, 2, anything up to 9, not 4. Well, 0 through 9, believe it or not, is 10 different possibilities because of the 0. And since we're eliminating 1, we have 9 possibilities. So in the case that the first and third digits match, we now have 9 outcomes. That's what we call it. 9 results, 9 possibilities, 9 outcomes. Well, what's left? We had the first 2 digits match, the hundreds and the tens. Now we treated the hundreds and the ones, so we have to do the tens and the ones. Again, we're forced with that. Only one possibility, since we're only analyzing numbers in the 400s. We know that the number is even, so it could be 0, 2, 6, or 8. What did I omit? So there are 4 possibilities here. And since the second and third digits are supposed to be the same, there's only one possibility for that. Let's actually list this. 4, 0, 0. 4, 2, 2. Remember, they have to match. 4, 6, 6. They have to match. And 4, 8, 8. So there are our 4 possibilities. So we did the first and second matching. And do you remember how many we got there? Let's go back and look at that. First and second matching, we got 4. Then first and third matching, first and third. And we got 9, and now we got 4 more. And if we combine all these different cases, I like to call them cases. So if we're in the 400s, we have 4 plus 9 plus 4 plus 4, which is 17. That's in the 400s. Now, what do you think we're going to do? Add another page. So if in the 400s there are 17, this should apply to the 200s whenever we start with an even digit, right? Because that's the case or the category we analyzed. The 600s and the 800s. Looks like we're all done, right? 4, 17, 68, yay! But I'm sure you know I also have conveniently omitted the odds. So let's pick an odd category where the hundreds digit is odd. So let's make believe let's do 7. Okay. Again, first and second matching. Then this would have to also be a 7 if the first hundreds and tens match. And then this could be 0, 2, 4, 6, or 8. 5. So in this case, we'd have 5. Now, we could also do first and third matching, which would be, that has to be a 7, and that has to be a 7. Uh-oh. We can't do that one. So the first and third cannot match if the hundredths digit is odd. Remember, it's even. So the ones digit has to be even. All right, we'll do the second and third matching. Again, this has to be a 7. We're in the 700s. That's the group we're analyzing. Now, it has to be even, so this can end in 0, 2, 4, 6, 8. Look familiar? And similar to this, since the tens digit and the ones digits have to match, this has to be the same, so there's only one way. So we have 4, 1, 1 again. Oh, this is 5. 5, excuse me. 0, 2, 4, 6, 8, like we did above, that's 5. So in the case that the hundredths digit is odd, we get a total of 10. Since the hundredths digit could be 1, 3, 5, 7, or 9, there are 5 groups of these, so it would be 5 times 10, or 50, for a total of 118. Yeah, I rushed it at the end there. So you're going to have to reanalyze this, watch it many times, and when you have a problem this complicated, don't try to remember everything I did the first time, unless you feel very confident. Just try to remember how I started. Did I start in the hundreds? I could have, but I didn't. Did I start in the 200s? I could have, but I didn't. So how did I start? So see what you remember. That's right, I started in the 400s, right? Where the hundreds digit is even. And then I analyzed that with 3 cases, and then I went to the hundreds digit being odd, and so on, to summarize. I'm guessing 99.9% of my viewers here are probably, they shut this video down after the first 30 seconds, and it's definitely way too long-winded. But go back, try it on your own, and let me know how you feel. Bye.